Alright, here we have our first phase shift. Alright, so here we go. Amplitude is 2. The cosine, actually, let's use green. Okay, the first, the period, since there's a 1 right there, the period doesn't change. Sweet. But we do have a phase shift. Now that phase shift says, well, it says minus pi over 2, but you always have to think the opposite when the change is happening inside parentheses, like so. So we're going to say that the phase shift is positive pi over 2. A positive pi over 2 means it moves to the right pi over 2. Our maximums, let's see here, the amplitude is 2, so we're going to go up to 2 and go down to negative 2. And because there's no vertical shift, I can just say that. If there's a vertical shift, then that's going to change these values. The amplitude would be the same, but it's going to change these values because the midline changes whenever there's a vertical shift, which I think we're going to see in the next graph. The y-intercepts, remember cosine starts at 2, or I'm sorry, at 1 normally. It would go right here to there, to there, to there, to there. Normally this is what the cosine function looks like. Normally it starts at 1, but because the amplitude is 2, it's actually going to go up to 2. So I'm going to write 2 for our y-intercept. For our x-intercepts, there is a horizontal shift. Oh, snap. Because there's a phase change, our x-intercepts actually change. But you know what? We know what they change to. They change by pi over 2. Normally, this would be pi over 2 right here. But if this point shifted to the right pi over 2, that means I would take this pi over 2 and I would add pi over 2 to it. And so that means that this would be pi. Okay, so that's one x-intercept. Let's put that right here. That's pi. And this normally is 3 pi over 2. Is that right? Yeah, 3 pi over 2. And then we're going to add pi over 2 to this one. That would make 4 pi over 2, which would simplify down to 2 pi. Oh. So this is our graph if we were just changing our x-intercepts. So I'm going to put 2 pi right here. Now what I did right here, just by adding pi over 2 to each of the normal x-intercepts, that's one way to find your x-intercepts. But honestly, I probably wouldn't do that normally. What I would do normally is I would graph my function first, and then I would look at my x-intercepts. And so to graph my function, what I would do is I would write down my new x values right here, 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 and here, and here. And the reason why I would do it this way is because it's kind of easier. See, normally it's 0. Normally we're starting at 0, and then this would normally be a 1. Okay, but we know that the amplitude changes. It's 2 instead of 1 normally. And we know that there's a phase shift of pi over 2. So if we actually shifted over pi over 2, then our first value right here is not going to be 0 anymore. It's going to be 0 plus pi over 2. So I'm going to put, not 0, pi over 2 right here. And then my next question would be, okay, so what's this one going to be? You know, actually this should be like going through right there. Let me fix that. Alright, that's better. Okay, what am I going to add each time to find my other x's? Something that would help is knowing the period. Now the period here is 2 pi. And because we have 1, 2, 3, 4 sections in this 2 pi, we just need to know like what it increases by each time. So I mean, this whole thing increases by 2 pi. You know, from the beginning to the end, it increases by 2 pi. But what does it increase by if it was broken up into 4 parts? So that all you have to do here is go 2 pi and divide it by 4. When we do that, we get pi over 2. And so that means each time we increase by pi over 2. So pi over 2 plus pi over 2 is going to be pi, because 1/2 plus 1/2 is 1. And then when we increase it by 1 pi over 2 again, then we're going to get 3 pi over 2, because you know, 1/2 plus 1, you know, 1/2 pi plus 1 pi, that would give me, see, that would be 2 over 2, that would give me 3 over 2, which is how I get the 3 pi over 2. And then I would just have to add pi over 2 again, which would give me 2 pi, and then I add pi over 2 again, that would be, let's see, 2 pi plus pi over 2, this would be a 1, but if I make that a 2, that would be a 4, it would be 5 pi over 2. So this is 5 pi over 2. So there's my x values. Now I'm going to come over here and use those x values to help me graph this. It's nice that our period is still 2 pi to kind of help us get used to this phase shifting business. At pi over 2, we're starting at 2. Okay, remember before how we would start over here? And so now I'm going to be drawing my graph something like this, you know, to graph my cosine. And then my ending point is 5 pi over 2. Now 5 pi over 2 is off my graph, and so let's see, let's just look at our next x value. Next x value is pi, so I'll go right there. Our next x value is 3 pi over 2, which is down here. Remember, my minimum is down because of the amplitude. And then my next one is 2 pi, which would stop me right there. So, and I stop right there because that's the window I'm given, but you know it would continue on like that. And then so over here, if I go work my way backwards, since I'm at the maximum, I would go back to the minimum point, which would be another pi over 2 distance over here, which would be over to 0. And there's my graph. Oh, that kind of looks like the sine graph. What? The sine graph is equal to the cosine graph. They call it a cofunction identity. If you take away or add pi, or pi over 2, add a pi over 2 phase shift to the cosine function. Okay, let's look at the next one. Alright, now things are getting a little hairy. And things get hairy when stuff like this happens. Okay, when you have a change in the period and you have a phase shift, ooh, that's kind of weird. And so I like to change this. I like to, well, not change it, but manipulate it so it's to my liking. And what I do is I factor out a pi. And the reason why I'm factoring out a pi is because I want to see what this is. If I factor out a pi, then there's a 1 in front of the x, and then I could really know what my phase shift is. And so I take out the pi, I factor it out. And when you factor, you're dividing. Pi over x divided by pi is just going to be x, and so I put an x right here. And then pi divided by pi is just going to be 1, so I have a 1 right there. And then I don't have a vertical shift yet. Okay, cool. So I know that my phase shift is -1 because it says +1 right there. My amplitude is going to be 2. My period, well, the b is what's multiplying to the x, so that's going to be pi. My period is going to be 2 pi divided by pi, you know, because it's divided by b usually. It's 2, so my period's 2. Ooh, that's interesting. Now my maximums are going to be at 2, and my minimum is going to be at -2. There's no vertical shift, and so I can just kind of copy or use the amplitude to help me find the max and min. The y-intercept, well, that's going to change because of the shift, and the x-intercepts are going to change because of the shift. And I think I'm going to do what I did the second time around on the previous graph. I'm going to first try to find what my x values are before I actually graph. Now, normally, the first x value is 0, and this is sine, like, oops, sine goes like this. Normally, my first x value is at 0. But because our phase shift goes back 1, I'm going to say that our first x is 1 instead of 0. Now this is the next part. What are my next x values going to be? Well, I look at the period and I divide that by 4, so I get 2 divided by 4. And the reason why I did that is because this would be the period, and the period is divided up into 1, 2, 3, 4 sections. And so I divide it into 4. And I get 1/2. So that means I increase by 1/2 every time I go down my x axis here. So -1 plus 1/2 would be -1/2, and then plus 1/2 would be 0, plus 1/2 would be 1/2, plus 1/2 would be 1. And so the total distance here is 2, which is my period. That completes the whole cycle. And now I have my amplitude to help me out with my points. And so I know this is going to intersect the midline right here. And then my next point is going to be the maximum or the minimum. Oh, it's going to be the minimum because of that negative value right there. Normally I would go up, you know, so we can do this kind of thing. Okay, but we're not going to do that kind of thing because it's a negative, so we're going to go down. It flips. And we go back to the midline and then up to our maximum and back to the midline, and so we have a graph that looks like this. That's really pretty. Hey, that doesn't look very much different than our other stuff. Well, it will look different once we get onto a normal scale right here. Now this scale kind of stinks because it counts by pi over 2. And look, our units right here count by 1/2. So what are we going to do? Well, this is kind of a mean graph, but because of the scale. But if you knew what pi over 2 approximately equals, which is, oops, I should use the approximate sign right here, 1.57, now you have an idea of what this number is, and you have an idea of where the 1 might be. and then bam, there's the rest of them. Okay, so we approximately know what all these are. So that means the 3 is approximately right there, because this is about 3.14, so that's going to be our 3. Where's going to be, let's see, 2 pi is 6.28, so that is going to be about, actually probably a little less than that, maybe right there is going to be our 6. And then I kind of divide stuff up. So this is going to be, and that's going to be, see, that's going to be 1, that's going to be 2. This is going to be 4, and this is going to be 5. Boom. Yeah, this is actually a lot nicer when you have this kind of scale, just counting by ones. So our window actually starts right here at 0. So I'm going to graph my point right there, and then if I go to 1/2, which is right between these two, 1/2 goes up to 2, and then at 1 we go down to the the midline. Then we're going to go down, then we're going to go to midline, then we're going to go up, then we're going to go midline, and we're going increasing by 1/2 every single time, so that we can get our beloved wave sine graph. And I just connect the little dots right here. Oops, I missed that last one. Oh, that's gonna bug. Alright, so let's get that, and bam. Oh, I kind of erased that 6 right there. Anyways, that's how you graph that one, and it has a phase shift. The next two are really gnarly, so they get another video.